glad to welcome you all today to our March webinar that is hosted by Fiber Connect Council MENA. Our welcome extends to our members and their partners. I would like to thank our council member, Comscope, as well in accepting our invitation and presenting today's webinar with an expert speaker talking about maximize the potential of your network and consider total cost of ownership and the speed of deployments and make your network future ready with Mr. Michel Vernimmen, Senior Field Application Engineer, MIA Comscope. Mr. Michel is Senior Field Application Engineer across Middle East and Africa at Comscope. He has been in the telecoms industry since 1992, and his career spans operations, R&D, sales, and FAE. Michel has vast experience supporting telecom carriers across EMEA and has helped deploy fiber-based networks in the African continent, bridging the internet connectivity gap in that part of the world. Michel brings a unique perspective to the FTTH industry thanks to his broad international and functional exposure. He is certified FTTH professional and multiple patent holder. For our attendees, please note that Mr. Michel will answer your questions once he finishes the presentation. You can type all your questions in the chat area. Mr. Michel, I'm very happy to welcome you today. Please have the full floor.
Good afternoon, and thanks for the introduction, and thank you all for being here attending the webinar. So as mentioned, my name is Michel Vernimmen. I'm a Belgian national working for Comscope and part of our FAE organization, and I'm based in Dubai. Now, so today we will talk about our approach to optimize your network, and it contains three elements, as you can see. We will start with an evaluation of your business and operational needs and what the drivers are for developing a successful business case. Secondly, we will look at selecting the optimal solution set and architecture to best suit your asset requirements. Finally, Comscope's reach doesn't stop at simply supplying products. We will investigate what value-add functions we can offer. Now, defining the right network is an exercise that includes many different aspects. We should look at the types of services that need to be offered, which could be influenced by multiple elements such as market dynamics, demographic drivers, internal considerations such as operational requirements, business matrix, and financial target and goals. Looking into constraints around geographic and regulatory requirements and review what type of infrastructure and network layout will optimize your return on investment. The first stage in the process is to evaluate your business and operating environment. Let's take a few minutes to look at some considerations and drivers which must be taken into account when considering what type of network you will deploy. Three elements that define your business and operating environments are service and roadmap. What services are you offering today and how will that evolve into the future? Understand the market dynamics and demographics, how the network will be used now and into the future. And finally, what internal KPIs and business drivers you have. Today, we will consider each one of these elements and how they influence the network selection. Let us look at the first one here, services and roadmap. It's clear that data consumption will continue to rise at an exponential rate as people and machines define new ways of using the internet and leveraging that data for future network requirements. This will drive additional data usage, but also at the same time leverage dependencies such as low latency, security, and quality of service. Ensuring your network can support your service roadmap and be scalable and flexible to meet the whatever, as we call it, demands are required moving into the future. Key is to maximize your return on investment. Physical ways of achieving this could include adding points of flexibility in your network, ensuring max, move, add, and changes can be made easily without the need for large-scale network remediation. When looking at market dynamics and demographics, we see that our industry is facing a trend of reduced annual revenue per user, but at the same time, increasing data consumption and increasing quality of service, which has led a lot of carriers to offer an unlimited data offering to the marketplace with no caps on speed, which limits the ability to increase revenue through tiered price structures, as you can see from the slide. Some strategies to address business metrics and financial targets include implementing the pay-as-you-grow philosophy, delay investment until demand comes online, can help to meet financial goals and drive a positive cash flow position. Technologies such as plug and play can help to quickly and efficiently deploy a network and at the same time offer benefits to network remediation in the event of a network outage. Having the ability to quickly turn up services and make fast customer connections can also greatly assist in improving customer satisfaction and retention. Here, we will dive deeper into some strategies around network selection and defining how this can play an important role in reducing total cost of ownership and maximizing your return on investment. We see three elements that can drive architecture choices: operational considerations, physical constraints around geographic or regulatory restrictions, and finally, the infrastructure itself. In terms of operational considerations for deploying a network, we must consider availability of resources, installer skills, and availability of installation equipment. Selecting the right equipment and architecture can greatly influence these decisions. Considerations into operating and network management systems must also be evaluated. Do current systems allow a good network planning, or are modifications required to handle a new type of network architecture? Product selection can be critical to address training needs and skill level requirements, but can also help to provide fast network turnup. We try to use our experience from network builds around the world to develop easy installation procedures for all our products. When looking at geographic and regulatory considerations, we should realize that selecting the right material for the application will not only improve the lifetime of your network, but will also help to reduce operational and remediation costs. As previously discussed, more and more connection points are required for today's network that will go deeper into the public domain, and this can lead to visual pollution. Ensuring that network elements can be blended into the surroundings can lower resistance to network build-outs and provides simpler permitting rights. I think that aesthetics needs to be considered when selecting the right solution for your network. Considerations into population density can often lead to the right network selection for the environment to be deployed. We will investigate different network selection choices later in this presentation. When looking at your network infrastructure, starting points are usually performance and quality. And as we all know, price or cost is not far behind in this case. This is obviously no surprise to all of us. However, the word price, cost, and value can mean very different things depending on the scope and vision what the user wants to achieve. When evaluating costs, organizations should always think in terms of cost over the life of the network infrastructure, rather than only the initial installation cost. Considering cost should include the following: initial production costs, initial installation costs, the ease to deploy basically, and the correct specification, avoiding unwanted extras and performance restrictions. The ease of operation and maintenance is also key. Operationally friendly product solutions are basically the point here we will stress. Last but not least, I would also say that make sure it supports the current and future applications, because we don't know what's coming, or we actually know what's going to come in terms of the latest GPON technology. Now, let us evaluate here basically the new architectures and product selections that could help to improve speed of deployment and improve flexibility of your network here. The network architecture selection is normally driven by housing densities, as we all know. In dense urban environments, all the connections homes will be located close of each other, which allows you to group multiple splitters into a single common location. When looking at rural applications, often the density of houses is very low. This type of environment typically doesn't lend itself to the same network construction as a dense urban environment. So a cascaded or distributed split architecture will be far better solution here. By using smaller cable sizes, infrastructure costs will be reduced, but many offer less flexibility of reconfiguration basically here as well. So one way of speeding up your network deployment, but also increase the amount of flexibility, is using hardened connectivity. Due to the fact that this is a very robust solution, this technology allows operators to use a lower skilled workforce if needed. Hardened connectivity is available for single and multi-fiber applications and can be used above and below ground, as you can see from the pictures. But make no mistake here, also in this case, the person who's handling the product needs to know how to clean a connector. This is very important. We see this happening, that the installers are not cleaning the connectors, and it hampers the optical performance. Another way of implementing flexibility in the network is using fiber distribution hubs. Now, this hub could be an underground closure or a typical street cabinet. We see now basically also a migration from the street cabinets to an underground closure more and more with our customers. Due to the construction, they are more suitable in rural environments, but they can reach higher fiber counts. That is a given. So let us evaluate different splitting architectures here. We will review two main architectures: the centralized split architecture, where splitters are co-located within a single location, leading to a point-to-point connection from the splitter to the premises. The second topology we will look at is the distributed or cascaded split, as we call it. In this type of network, the split ratio is spread throughout the network, with the primary splitter feeding multiple secondary splitters. The second approach will reduce the fiber requirements within your network drastically. Looking in more detail at the centralized split architecture, you will see there's only one location in a network where splitters are located. The product to house the splits could be either an underground closure or street cabinet. This type of architecture will optimize your PON port utilization, but it requires a lot of fiber, specifically in the distribution side of the network. When considering a distributed split network, there are a lot of possibilities actually that can be leveraged depending on the housing density environment. We will examine three types of distributed split topologies in further detail. We will look at the cascaded split, the fiber indexing, and the optical taps. The cascaded splitting. In most cases, a cascaded or distributed splitter approach has no splitters in the central office. We all agree on that one. A first splitter is installed actually in a fiber closure or a fiber distribution hub, not far from the central office. The second level of splitters will be located in terminal boxes, very close to the customer premises. Normally, we see that each splitter is covering 4 to 8 homes. In a cascaded topology, the amount of fiber required is much lower. In the network distribution portion, the area of the network with the greatest impact on the overall cost of the infrastructure. If we're looking at the fiber indexing, for instance, so let's say in a few words, what is indexing? Well, in short, it's an innovative way to build the distribution network. The indexing begins with a 12 fiber cable entering the first terminal starting from the fiber distribution hub. In the terminal, fiber 1 of the cable is routed to a splitter, a 1x4 or a 1x8, for servicing nearby homes. The remaining fibers are indexed, as we call it, or moved up or shuffled as they exit the terminal to connect to the next terminal. Indexing means that the second fiber entering the terminal will exit as the first fiber to enter the next terminal, and so on. And this is in a daisy chain fashion. So important for you to remember actually is that fiber indexing has a potential to reduce construction and civil work costs in the distribution network by a whopping 70%. And in the process, significantly reduce deployment times and speed up time to market. One key saving lies in the length of cable needed. It's made possible by changing the network topology and consolidating the functions of multiple network elements into the service terminal. I encourage you also to watch the video on YouTube that we provided to have more details on this topic of fiber indexing. The other one I would like to discuss is the optical tap. So a distributed optical tap architecture is totally different. It uses fiber optic taps instead of splitters, and there is no fiber distribution hub utilized. The optical taps are deployed in a linear daisy chain topology. So imagine taking a fiber in a fiber cable, you cut it in the middle, and splicing a fiber optic tap to that fiber. Now the signal can pass through the tap and continues down the fiber, while the tap siphons or drops off a portion of the signal for locally connected subscribers. Multiple taps can be placed where needed down the line until the optical link budget is exhausted or the maximum number of subscribers per OLT is reached. Typically, what we see here is about 20 to 56 homes maximum supported for each tap run. The rural taps are also available in 2, 4, and 8 port models, depending on the number of drop ports required. For each model, different tap values, and they range from -4 dB to -22 dB, are available depending on how much optical power should be dropped off at each location. So drop ports from the tap are pre-connectorized to facilitate a simple connect and disconnect of the customer drop cable. Now, in the previous slides, we talked about the physical shape of your network and how it can help you to be more flexible and optimized to be future ready. Now, obviously, you can also look at the option to converge services over the same existing physical outside plant network, right? So here, fiber networks convergence refers to the delivery of residential, business, and wireless services over a common fiber of your network infrastructure. So mainly wireless networks are experiencing rapid growth, as we all know, and these deployments will require new and existing fiber networks to meet high bandwidth and specifically low latency performance requirements as well. With the converged networks, a service provider can efficiently and quickly deliver a wider range of services, obviously, and adopt new business models. So innovate new services and maybe even new markets. That's also a possibility that we see. One way to optimize the existing outside plant infrastructure could be the use of passive WDMs, as you can see here. And WDMs can be used to add capacity to an existing network through wavelength multiplexing, overlaying multiple signals to an existing infrastructure, basically. So there's no digging to add more fibers. These components that can be located in the optical distribution frame at the central office at one end, and enclosures or even in boxes at the other end of the network. Now, the trends we see, they're moving towards using DWDM instead of CWDM. And the biggest driver is actually the price of the transceivers. So more channels equals more capacity. And however, C and WDMs, they can coexist on the same network. This is possible as well. So here, finally, after the network and business case choices have been made, it's time to deploy, right? So CommScope continues to support you throughout the entire network lifecycle in this case. We offer multiple levels of support and consultation throughout the entire decision-making process and beyond, from self-service support, for instance, leveraging the vast array of information and documentation available on commscope.com, with dedicated customer support structure, through to on-site consultation and even full turnkey service offerings where we can provide dedicated resources for network design, planning and implementation through our professional service offering. So we have quite an extensive team doing that. By the way, on the CommScope website, you can also find more information like product documentation, technical support, we have training, we have webinars, all the videos are available, calculators, data sheets, compliance statements, and so on and so forth. In case of our FAE team, we are located globally, so we support you locally as well. We're working with customers to identify the product solutions for the application, depending on topology requirements, architecture, and so on. And that provides basically a short-term and long-term value. We do technical pre-sale support, consultation capabilities, and solution recommendations, as well as post-sale support. In that case, it's installation assistance, product training, and on-site field support. We also provide detailed bill of materials for customer projects. We do network modeling with estimated costs. We do product advice and identification of product variants as well. Field trials and project support are also covered in this case. What is new for Comscore is our capability to offer professional services. So the capabilities, they include walkout, digitization and design, field walkout, network design, civil work maps, planning. We do even the permit management as well. We prepare the required documentation. We do follow-up about the status of the permits, material supply and general management. We do the construction services, production reports, guarantee of compliance with the customer's construction quality standards as well. And of course, the network certification and project closure like ATP tests, like optical power measurements, fiber characterization tests, OTDR testing, and so on. Now, to complete today's session, I would like to discuss two case studies that we did. So the first case study is based on the fiber indexing technology. So you see the picture here of what fiber indexing is, so the shifting of the fibers. So it's one fiber position from one multi-fiber connector to another, and this within each terminal. So you can see it again from the picture there. So to find a new way to compete with the large service providers, this specific telco created a specialized broadband business. So the service provider, they wanted to do a test case with a fiber indexing solution to see if it would allow them to deploy faster with less fiber, which is the key using this solution. They claimed that the results were very encouraging. So the telco, they called the no-splice connectorized technology genius for its layout, loss calculation, and speed of deployment. In the deployment that followed, the telco installed aerial distribution hubs that allowed fiber cable to cascade down streets on pole lines in their case. The pilot phase of this project involved 6 locations, and we served about 150 homes. Fiber indexing terminals, they were placed on telephone poles, and we linked them with multi-fiber cables in a linear, cascaded fashion. The second case study, this is about a European electricity utility company who decided to build their own open access FTTH infrastructure. So 2 very important technical modifications I would like to mention from this case are actually the change from splice terminals to hardened terminals to reduce the splice cost. And also the move of the splitters from the street cabinets to splice closures to reduce the civil works. In some countries, they don't like to have the fiber distribution hubs and are migrating to basically splice closures, integrating the splitters there as well. And most importantly, we did this during the rollout. Okay. And to end basically this webinar, this is the customer statement from the case study. So that shows, in my opinion, basically the importance of our local presence globally. So we're sitting in Africa, Middle East, Europe. I mean, the sun never sets on Comscore. We are a global player. So, and this is really nice from that operator, that national utility that goes broadband basically with this statement. So by this, I would like to thank you to attending this. And if there are questions, please shoot. I'm available to answer them.
Thank you so much, Mr. Michel, for this informative webinar. I would like to ask the attendees if they have questions to type in the chat area their questions. Meanwhile, Mr. Michel, I have a question. Which topology would be most efficient for a rural deployment or very low density?
Well, that reflects on the presentation, really. So what we recommend is, and we have been deploying, is basically the tap technology for rural areas. So far, we passed, or we connected 400,000 homes on these rural areas. The biggest advantage actually is that you minimize the length and the fiber counts of the cables. So because the densities are very low, right, in rural areas. So this is a key aspect. And depending on the demography, we have studies and independent studies basically that show that we can save 15% actually in total on the TCO. And this includes actually the material and installation cost.
Perfect, thank you. So someone is typing the chat area. Let's wait to see the next question. Okay, meanwhile, another question, Mr. Michel, regarding the WDMs. Do you see WDMs being implemented in big FTTH rollouts today in EMEA?
That's a good question. There are two basically answers. So some big operators, they have decided to go to combo cards, right? So that will integrate GPON and XGS-PON in the same output. So there is no need for WDMs, but in other big operators, they definitely go to WDMs, and this is more called coexisting modules, actually, because there they guarantee a more flexible path to change technology. Not basically from GPON to XGS-PON, but later to 25-PON or 50-PON. So it keeps the network independent, and this is really key. It keeps your network independent from the active equipment supplier.
Okay. We have another question. So from Mr. Rajorama, referring to cascading splitting.
Yes.
He said that he has doubts on lost budget.
Well, that's a good point. I mean, obviously, you need to do a link loss calculation. I mean, by adding splitters, some cases operators are using plug-and-play splitters, so they're already pre-connectorized. And then you have the mating loss of the connector, which is a point, and also the manipulation and the skill area. If there's hygiene on site in terms of if they're cleaning the connectors by repatching and doing move add-in changes. As I mentioned, today we see a tendency that operators are basically migrating from fiber distribution hubs, which is a connectivity area, let's face it, to underground full splice solution to avoid these optical losses.
All right, we have another question from Mr. Du. Noted that your PPT was edited in 2020 and now the cable market is quite different since 2 years before. And your calculation mode on the budget is flexible for the basic data input, right?
Yeah, I mean, there's a mistake in the apologies for that in the date. I mean, the data that we show here on the slides are still valid today. If we see the technology using taps and other technologies that we just discussed, this is still valid and implemented as we speak. That is a given. Yeah. The use of WDMs, as we discussed, as well, the combination of CWDMs, the fiber indexing, which is a key today. We see also a lot of pre-connectorized solution, let's say for disaster recovery. We had some major hurricanes on a few Caribbean islands a year ago and 2 years ago, and then the whole telecom infrastructure was destroyed. And then we were approached by these telecom operators to go full connectorized to speed up the installation. And it was a very successful, let's say, implementation of these fiber indexing and optical tap, as well as a pre-connectorized solution as well.
That's great. So another question, is hardened technology more expensive and how much compared to standard connectivity in outdoor deployments?
Good question. So the hardened technology was basically developed and implemented 10 years ago, 12 years ago, right? When it was launched. So, but over the past years, actually, the volumes that we deployed with this technology, with all the big operators in the world, that made the technology much cheaper. And it is basically at the same price level as standard technology nowadays. So, depending on the exact topology, it can be cheaper or as expensive or as cheap as the standard technology, as I mentioned. It all depends on the planning, actually. So the take rates, the number of spare fibers, the type of elements. Are you going to go to pre-connectorized drops? Are you going to go to a combination of pre-connectorized feeded by spliced feeder cables or distribution cables? At the end of the day, actually in EMEA, what we see going for standard connectivity or hardened connectivity doesn't depend anymore on price. It is equal. That's what we see in the market today. Yeah. So, and also discussing on the skill level, it is hard to get skilled people nowadays. So if you have a pre-connectorized offering, you don't need that high skill level. Basically, it's just having the connector plugged into your terminal and at the customer premises. If the customer now, for instance, goes for a very low quality network with not the right ingress protection ceiling for outdoor and with not the right performance for the connectivity, then yes, it will be more expensive, obviously, but it will be cheaper than standard connectivity. That's what we see. So there's a minimum level of quality required by the big operators, right? Both technologies can be used at the same time, and they have the same level, price level, I would say. Yeah.
Perfect. Another question from Mr. Lu, is your design on FTTH a set of standard package or combination, or it is up to the customer specific scenario upon your site survey?
Well, first of all, we go into a high level, let's say, design overview in terms of country specific regulations, how the operator is seeing the topology, the architecture going. There's a combination of both architectures that we see. So you have a centralized split, you have combined with a cascaded split. It's all based on the initial discussions with the customer. And then based on that, we're gonna glue the equipment on that topology and on that architecture, and also on the input of the operator. Does he wants to go full splice? Does he want to have a combination of spliced and pre-connectorized? Do they want pre-connectorized splitters? Do they want redundancy? What is the optical link budget? What is the class of the GPON used, and so on and so forth. So it is it has multiple facets basically, and we always come with a perfect match actually. But it's a combination of having discussions with the operator, with the implementation team, as well as the inside plant and the outside plant, and then we come up with a full architecture and topology based on the requirement of the country and the regulations as well.
Okay, so another question, is pre-connectorized accessories another name of hardened technology?
Yes, that is correct. So what we talk with hardened, let's say you want to connect a villa somewhere in the Middle East, in Saudi or Dubai, then we have a terminal and the outside plant in a street. And this is called a hardened terminal. It's a multi-service terminal. We call it an MST. So the connectivity resides at the outside of that closure, and it's IP68. Then you need to run basically a patch cord from that pre-connectorized closure, let's call it that way, to the customer. And that is a hardened patch cord, basically. So the connectivity is hardened. It's IP68 with an APC interface for the connector. And going to the house, it can be also fully pre-connectorized as well, or it's going to go spliced inside the house. So the customer or the operator has a choice to do that. But from a fast deployment perspective, it is a hardened patch cord from the multiple service port, the closure basically, with the connectivity at the outside of the closure, going towards the customer premises. And this is done in a few minutes time, and it just requires a patch cord or hardened cable or patch cords, if you will, both sides connectorized. The connectorized portion on the customer premises is not hardened or not IP68, which makes no sense, obviously, because it resides in an indoor environment.
Okay, so I guess Mr. Du also he was connecting on the PPT. It should be up to several issues in different countries. I guess he was commenting on what you say, Mr. Michel.
Yes, absolutely. So different countries have different mentalities and different operating structures. If you look, for instance, in Europe, it's completely deregulated, right? I mean, every operator needs to give access to other operators, private operators, even municipalities, city operators onto their network, even on the last mile. So there's a combination of a lot of factors that we need to take into consideration, specifically in planning FTTH networks. That is a good point, actually. Yeah.
Okay, and also he was commenting on the water resistant IP68.
Yes.
Another question from Mr. Mohammed. Have your company done any project like national backbone in Africa?
We work with several operators in Africa, where we do long distance as well as NBB projects with them as well. Yes.
Perfect. So, Mr. Mohammed, also we can share with you the contacts of Mr. Michel and Mr. Mohammed Ghazali in case you need more questions to ask about the project. Maybe they can provide you with more details about it. So, also Mr. Du, he said yes, Europe and North America popular for hardened technology. So we have
That is
also,
correct. That is
yeah.
correct. But I mean, I have to say as well, in the Middle East, we have operators that are using hardened connectivity. And then the hardened connectivity, even the link to the house resides outside of the villa. So in most of the cases, the limit, you're limited in time to enter these premises. So you don't need to spend, let's say, half an hour to an hour to do the installation in house. It only takes a few minutes to do that, and this is also key to certain countries actually to do this in a few minutes, and also the skill level. Obviously, you don't need a splice crew, etc. You just have a team with the hardened cables going from the terminal towards the house.
Okay. So Muslim countries, yes. So we have also someone is typing also. Normally, the installer could not get inside the houses.
That is correct. Yes, that's what we see in some Middle East countries. Correct. Yes.
Yeah. Uh, yeah. So if anyone also has any questions, you are welcomed to type in the chat area and ask Mr. Michel. It's a good opportunity to ask a veteran in the industry. So I guess we have another question. Okay, please confirm that you are sure this is a good technology of hardened one.
Yes. What I can say is that the hardened connectivity was basically developed like 15 years ago. It's a well-established technology, the hardened connectivity. As one of your was one gentleman was saying, okay, the hardened connectivity, we see it obviously more in the United States, in the Americas, and in Europe. But we see it also now more and more implemented in our region, in MEA, as well as in Asia. So it is an established connectivity method to connect premises for sure. I mean, we see this more and more, again, because of the skill level and also the very fast deployment of the hardened connectivity. It's much faster to deploy than going with a spliced drop cable to the premise. That is a given.
Okay, but probably in the last 3 years after someone authorized their patent to some other one, since last
Well,
3 years.
yeah, the hardened connectivity, I mean, there are multiple players on the market, obviously. And also you need to make sure actually that your hardened connectivity is also compatible with other hardened connectivity, so that you can have multiple vendors. That is a given. I mean, I'm saying this from a technical perspective, yes.
Okay, so I guess someone also is typing. Okay, there are some copies in the world now. It's okay, Mr. Duweb. You are welcome to share all your ideas with Mr. Michel. No worries. So, Mr. Du commented that there are some copies in the world now. Mr. Muhammad Ghazali, there are many companies who have the hardened technology. So, no worries.
Yeah, for sure. Yeah.
Perfect. So, I guess, all right. Someone is typing also. Yeah, it is a trend now. All right. So I guess at the end, I can only thank you, Mr. Michel, and Sausan also from Comscope for your efforts in planning this informative webinar and for your time. We hope all attendees enjoyed enjoyed it and learned as much as I did today. Looking forward to welcoming you all to our next webinar. We will announce all the details soon. Thank you so much, Mr. Michel, and for all the attendees, we will share the contacts of Mr. Michel and Mr. Muhammad from Comscope in case you need to reach out to Comscope and have more questions or you want to get more information about today's webinar. Thank you all so much. I hope you will all have a very good evening. Thank you, Mr. Michel, and thanks for all the attendees who joined us today.
Thank you very much. It was a pleasure.
Thank you.
Thank you.